Dear audience, today present a topic selection and preparation of land. Introduction. Along with atmosphere, soil constitutes the natural media for rich support to the plant's growth and earth's surface. Soil is perhaps the most important of the plant derive their most essential nourishment from it. It is not only serves as a reservoir of food and water needed by the plants, but also provides a mechanical anchorage for them. Furthermore, the air circulating in its pore space to aerate the plant roots. In simple, the soil may be defined as in a thin layer of earth crust made up of disintegrated and decomposed rocks containing complex mineral compounds, organic matter, water, air and living organisms like bacteria, fungi, protozoa, insects, worms, etc. In sericulture, mulberry plants are cultivated for leaves are only sources of food for silkworms and cocoons are produced for making silk cloth. Besides the cocoons, various other products are also obtained, the utility of which is being intensively studied. A part of the findings of this study has already been implemented. Some of the byproducts are found to be useful. In case of the mulberry plants, the root, shoot, unflucked leaves, fruits and seeds are used in several ways. Today, mulberry is cultivated in about 2.90 lakh hectares in India and the stress is upon productivity. Earlier, the mulberry production per hectare was around an average of 12,000 to 15,000 kgs of leaf under irrigated condition. Presently, the average production has been tremendously increased due to the adoption of new technology like proper maintenance of mulberry garden and planting high yielding mulberry varieties, while the average mulberry leaf production per hectare has enhanced from 25,000 to 35,000 kgs. Objectives: improvement in living condition of rural peoples, positive involvement of rural peoples in managing the environment, managing natural resources in a sustainable manner, increased productivity from land and water, strengthening of community participation, improved socio-economic conditions for disadvantaged groups, especially for women's activities. Further, sericulture had proved to be economically more profitable than other crops. All the sericulture activities are village based and hence prevent migration of people from rural to urban areas in search of job. Sericulture could be a more advantageous agro-industry for improving the country of the deprived section of the society like scheduled caste and scheduled tribe. The marginal and small farmers opted for sericulture since it was a remunerative crop as compared to other competing crops like ragi, jowar, paddy, potato and other vegetable crops. The main reason being that a number of cocoon crops raised on a given piece of irrigated land could be anywhere between 4 and 6 crops per year. Land selection. Land selection is the first step in establishment of mulberry garden when the crop to be grown has already been decided. It also includes the selection of the right geographical location. This is so with corporate investors and enterprising individuals with sufficient capital. They would have realized that engaging in the commercial production of certain crops in a sound business venture. The mulberry garden may be located near to the rearing house or region of their residence. The land use methods which are agronomically and environmentally appropriate are determined first and foremost by the characteristics and location of the small landholder's field. If the plots are small and scattered, use of machinery is not possible. Labor intensive methods are anyway usually more appropriate than capital intensive for small landholders. If the land is steep or exposed, wind and water erosion control measures are essential. These can be costly and are not always easy to install on an individual farm basis. If the rainfall is low or unreliable, irrigation is necessary. Choices have to be made on the best method of applying and managing irrigation water. If the area is subjected to flooding, drainage and flood control measures are needed, again costly and not always easy to install on individual farms. If the fertility of the soil is low, fertilizer applications are being needed. Choices have to be made between organic and inorganic methods of enhancing soil fertility. If the area is subjected to buildup of pests and diseases, plant production measures have to be taken. Choices must be made between biological and chemical methods of prevention and control. As a broad generalization, areas which do not require heavy investments in agricultural machinery, erosion control, irrigation, drainage, chemical fertilizer or pest control measures as prerequisites for sustainable land use are likely to be more appropriate for small landholder cultivation than those which do require such investments. Location of land. The selection of a suitable land also follows when an individual decided to go into the garden. The purchase of landlord being considered as a better alternative of investing hard earned money rather than depositing in it a bank. Here, one of the most important consideration is the value of the property, that is, the selling price is as low as can be reasonably possible. Other factors being considered are water supply and those which make the farm suitable to a wide choice of crops and investment opportunities. The soil requirement of a particular crop includes such specific characteristic of soil type, depth, drainage, texture, organic matter content, soil pH and fertility with respect to the macronutrient and micronutrient content of the soil. The topographic requirement of a crop refers to its manual adaptation or tolerance to the land features such as elevation, slope and terracing. Where the crop to be grown has already been decided, some factors to consider in both location and site selection are as follows. Soil topographic and climatic requirements of the crop. Consistent with the rule know your crop first, then select the farm. The first part in the planting stage before site selection is to learn everything about the crop to be grown. This involves a thorough identification of the environmental adaptation of the crop, particularly its soil, topographic and climatic requirements. The climatic factors that can influence the growth and yield of mulberry crops include temperature, water or rainfall, light and wind. These factors vary with geographical location and has to be microclimate from farm to farm. Plants are also distinguished into various classifications according to climatic duration, relative humidity and adaptations such as temperature, subtropical and tropical crops. Biotic factors and the prevalence of pests and diseases. Site selection may consider the natural population of certain organisms like bees and other pollinators, where the sericulture venture involves the production of civet coffee farmlands adjacent to the forest areas may be preferred, but places with a long history of the presence of serious pests and diseases may be avoided. Likewise, caution should be exercised in choosing farm sites dominated by weeds which are difficult to eradicate. Cost of acquisition or lease and in preparing the land. Where financial feasibility or affordability is a consideration, the cost of producing or leasing the farmland is a limiting factor. This may be taken into consideration. Also, the cost of modifying the physical feature of the land, such as in flattering or modifying the landscape if so desired, the removal of barriers like unwanted trees, clumps, stumps and boulders, diversion of footways, construction of drainage, roads and fire lanes, and in preparing the land for crop growing, including the eradication of major weeds and disease causing organisms, soil amendment and provision of irrigation water. Accessibility. A farm that is managed as a business must have access to supplies, equipment and the market. It must be provided with infrastructures, example roads, and if the product is intended to marketed elsewhere. Moreover, there is a general preference for farms in familiar locations and which are easily accessible to owner managers. Labor supply and cost. Skilled labor must be available at a reasonable cost. Otherwise, laborers from other parts of the country may have to be imported. Mulberry trees need light and adapt easily to the soil. The site of the mulberry plantation must be chosen in accordance with the specific location condition of the land use. To take advantage of all potentiality productive land, mulberry trees can be planted on hilly lands, on the bank rivulets, on footpaths between rice fields and in the margins of cropped land. Plantations should not be located too close to mines and factories which are subjected to pollution, as this will hinder the mulberry growth, contaminate the leaves and endanger the silkworms. It is absolutely necessary to ascertain the location of nearby factories, what they produce, how large they are, the altitude of smoke pouring from their chimneys, the wind force, the landform, the weather and microclimate in the vicinity and other factors before the mulberry plantation is established. The plantation should be at least a kilometer away from ordinary factories and mines, at least 10 kilometers away from factories making aluminium produce. Before the establishment of a plantation, local environmental condition must be investigated. Data on water sources, drought, waterlogging, storms and other natural climatides and the history of insect pests and previous crop should be collected in order to determine the best location and to work out a comprehensive plan for setting it up and for its management. When the location for a large mulberry plantation is determined, the highest priority should be given to the position, dimensions and distribution of silkworm nurseries, the special mulberry garden for engaged silkworms and mulberry nurseries. Investigation and measurement. After the location and dimensions of mulberry plantations are determined, investigations and measurements should be carried out on landform, general configuration of the earth's surface, soil circumstances and the surroundings. Leveling of land. Land should be leveled before planting. If the land is undulating, the mulberry plantation will not conserve moisture and fertility in the soil evenly and the mulberry plants will grow unevenly and irregularly. This will make it difficult to care for the plantation and will affect size and stability of the yields. Climatic factors. Generally, the Indian climatic condition of all states are favorable to grow mulberry. The tropical temperature ranging from 23 to 28 degrees Celsius, but at low temperature below 13 degrees Celsius and above 38 degrees Celsius, the sprouting of buds and growth of mulberry will be affected. The favorable plantation season for mulberry is early monsoon. However, if abundant irrigation facilities are available for mulberry can be planted at any time. The dormant season for growth of mulberry is November to March in temperature zone, and rearing could be conducted only during May to October. In the tropical zone, and rearing could be conducted only during May to October. In the tropical zones, this problem does not arise and mulberry grows all throughout the year under favorable conditions. Always plantation season must be selected as per the above specified recommendations. Too cold or too hot seasons badly affect the growth of mulberry. The mulberry can grow very well within the range of 600 to 2500 millimeters rainfall annually. Mulberry growth will be considered optimum in elevated areas above 600 to 700 median sea levels in MSL. Soil suitable for mulberry garden. Selection of soil is of prime importance in mulberry cultivation. At the time of selection, it is to be remembered that the quality of soil mulberry field has a profound influence not only on the mulberry leaf field, but also on its quality. The fertility of soil ultimately affects the growth of the silkworms and thereby quantity and quality of the cocoons produced. In this aspect, mulberry is quite distinct from other crops like paddy, wheat, etc., as comparatively their quality is not of so much importance. The soil of mulberry plantation must be capable of maintaining the mulberry plants for prolonged maximum productivity of quality leaves. The ideal mulberry soils are the ones which contain adequate amount of all essential elements in the forms readily accessible to plants or in good physical condition to support and contain just the right amount of water and air for desirable root growth. Since mulberry is a deep-rooted, perennial, odd and monocultural crop, the soil should be capable of supplying sufficient air, water and nutrients even in the deeper layers where the rhizospheres are exist. The soil should not only contain the essential elements, proper amount of air and water, but also it must be available to mulberry plants regularly. The mulberry is tolerant to a wide range of soil conditions. It grows well on loamy soil or high fertility. In general, the soil for mulberry should be deep, well drained and clayey loam in texture, friable, porous, fertile and with good water retention capacity. Soil pH. Soil matters more in the growth rate of any plant. Mulberry grows in a wide range of soils. Mulberry is a deep-rooted perennial plant. Therefore, the soil with good water holding capacity and good aeration, good air penetration is more suitable. Soil ranging from clayey loam to loamy soils, slightly acidic soil is ideally suitable for mulberry growth. Slightly acidic soils ranging the pH from 6.2 to 6.8 reveal healthy growth of mulberry plant. One of the outstanding physiological characteristics of the soil solution is its reaction, since the microorganisms and higher plants respond to markedly to their chemical environment. The importance of soil pH and the factor associated with it has long been recognized. Slightly acidic soils with a pH value around 6.8 free from injurious salts are ideal for good growth of mulberry plants. The acidic as well as alkaline soils are not suitable for growth of mulberry, but both types of problematic soils, acidic and alkaline, are encountered in tropical mulberry gardens. Division of operation area. A large mulberry plantation can be divided into a number of operations areas or basic units of tillage in accordance with land form and the physical feature of the land within the jurisdiction of the plantation administration. A suitable size for one operation area is approximately 1 hectare or little more. If the plantation is situated on a flat land, it can be a little larger. If it is in the hilly country, it can be little smaller for the purpose of water and soil conservation. If the major production processes are mechanized, the operation area should not be less than 100 square meter for efficient tractor plowing. Land preparation for irrigated mulberry garden. When establishing a new plantation, certain actions need to be implemented to ensure the long-term success of the plantation. One of these actions involves the initial land preparation, which should be done prior to transplanting of the planting material. The purpose of land preparation is to provide the necessary soil condition which will enhance the successful establishment of the young shoots or the tissue culture plants received from the nursery. Land should be prepared by deep plowing up to a depth of 10 to 12 inches in order to loosen the soil before planting, taking advantage of the pre-monsoon showers during the April to May. Therefore, the land may be plowed once or twice with a light flow or country plow to bring the soil to a fine tilt. The land should be properly leveled. Afterwards, a basal dose of organic manure like compost or farmyard manure means FIM should be applied at the rate of at least 10 tons per hectare for rain-fed and 20 tons per hectare for irrigated mulberry garden. Finally, the manure should be properly incorporated into the soil by plowing and the land leveled and made ready for planting during the monsoon rains of June to July. It must be stressed here that application of basal dose of organic manure like compost or cattle manure is essential for successful initial establishment of the plantation. Under very exceptional circumstances where these are not at all available, an alternative may be resorted to by growing nursery raised plants and transplanting them into the main field. Land preparation for rain-fed mulberry garden. Generally, pit system of planting with wider spacing should be adopted for rain-fed condition, and row system with closer spacing can be adopted for irrigated mulberry garden. Therefore, for planting of mulberry under rain-fed condition, pit should be dug at a spacing of 3 feet into 3 feet. The pit should be of the size 35 into 35 centimeters, at least 35 centimeters deep. These pits are filled with soil, preferably mixed with some cattle manure in the pits. The cuttings are rooted, saplings are planted. In the case of irrigated gardens, the prepared land thrown into furrows and ridges. The cuttings are later planted along the edges of the ridges. It may be noted that there is only one irrigation channel for every 2 rows of mulberry plants. This helps in both saving and more effective use of the irrigation water. Cuttings and planting. Juvenile branches of 8 to 10 months old and about 50 millimeter in diameter should be used for the preparation of cuttings of 22 to 25 centimeter length with 3 to 4 healthy buds. 3 cuttings are planted per pit in a triangular form with a spacing of 15 centimeters, leaving only one bud exposed above soil surface. If planting is done with sapling, then one sapling is sufficient per pit. Planting should be done during June-July after the onset of the monsoon. Availability of water. Although not always realized, the mulberry plant requires a rather moderate quantity of water for sustainable growth. Critical factors regarding water for irrigation purposes are the sustainability of the water sources, the quantity of water available for irrigation, the distance of the field and the quality of the water. Soil depth. In time mulberry plant grows very well, therefore it needs sufficient water for proper root development to support the mulberry plant. Besides the importance of root development, soil depth also influences the drainage and leaching possibilities. Any obstructive layers must be evaluated to determine whether they will influence root development and whether they can be corrected. Soil quality. The optimum soil conditions are found to be where the water can penetrate to at least 2 meters deep. When evaluating the soil quality, attention must be given to the soil texture, which will influence the water retention capacity, and the nutrient content to determine the corrective measures necessary for soil improvement.